Okay, 13. Key thing is make sure you know what you're looking at. It says the graph of f is shown. As I mentioned, they don't always label the graph, so read carefully. So we're looking at f. It says the graph of f has a vertical tangent at 2, 0. So right here, there's a vertical tangent. That means right there, the slope, tangent slope of f at x equal 2. Okay, hands up everybody. You're not going to want to write that very often because it's too many symbols. What is the compact mathematical way to write what I just wrote in blue? What's the compact mathematical way to write that? Hands up. We've learned this, but we haven't practiced it much, so if you don't remember, it's okay. What is the mathematical way, Drew, to write that blue sentence instead of writing all those symbols? What's the short way we can write that?
Is it df of x over dx?
You'd have to say at
x equals 2.
Perfect. 2 points for Drew. This means the same thing as that blue. Okay, this is the math way to say it. This is the English way to say it. Question. Oh, please.
Couldn't you also do TS equals 0 or TS equals 2?
I've done that before. They won't let you do that on the AP test. Like I did that to kind of make your notes a little shorter. This is legit. Like you write this on the AP test, that means exactly the same thing as this.
So if you write the words on the AP test, will they dock you? Like, do you have to write that?
Tricky thing to answer. Not necessarily. But if you don't know, 2 for Paisley, if you don't know that this is the same as this, you are likely to lose a significant number of points for not knowing that. You're probably free to write either one when you're describing something. What's that?
But just like...
It's a little quicker, you know, a little quicker. There's an even shorter one, 2 more for Paisley. Who knows the shorter one to write? The shorter math way of saying both of those green statements. Let's go, Benson.
PT equals 2.
That would be true if the graph of f were graphing position. It's not necessarily doing that, so we can't do that. 2 points, though. Let's go, Spencer, sorry.
F prime of x.
There we go. And because we're at x equal 2, you actually write f prime of 2.
Okay.
That's the shortest way to write what we've been talking about. And my recommended way is that. So, Conrad, please.
So the derivative, the graph of the slope is f prime of x. The tangent slope is the derivative point for that specific spot.
2 more. Tricky to say because we could say f prime is a graph of all tangent slopes of f. This is just a specific tangent slope at one point. 2 more. Okay, more, please.
So for the notation with the f of x, where does that say that the slope is 0? Like.
Oh, I did something bad. No one caught it, except maybe Cora. This should have been 2. I need an is here. I don't have an is yet. Let me just pause for it. Let's see if this helps. Hey, look. Okay, it said that at x equal 2, there's a vertical tangent. Hands up. Don't say it out loud. What is the slope of a line that is vertical? Hands up. What is the slope of a line that is vertical? What is the slope of a line that is vertical? Let's go, Ellie. Well, this is undefined. Who agrees? 2 points. Vertical lines have an undefined slope. Some people like to say the slope is infinite or negatively infinite. I kind of prefer that just because I feel like it gives us a little more information. But it's technically, I don't know, they'll kind of accept either one. You're good. So we could say f prime of 2 is undefined or non-existent or whatever, we don't know. Okay? That's what they're telling you. Pretty good? Okay. Keep reading. Horizontal tangents at 1, -1, excuse me, right here. Hands up. What does horizontal tangent mean? Hands. What does horizontal tangent mean? Half of you. It's going to tell you.
Slope is 0.
Slope is 0, 2 points if you knew. So you could write that as this. F prime at x equal 1 is 0. And you could write F prime at x equal 3 is 0. That's what horizontal tangent means. Please, Paisley.
So, is f prime, or is the tangent just the derivative of like the function? Like,
Let me say it back to you. Your thinking is right where it needs to be. I'm just going to change the wording a little bit. The tangent slope of f is, like all the tangent slopes of f is the same thing as the derivative of f.
okay.
Same thing. Is that your question?
Yeah.
Yeah. So so right here, Paisley, the tangent slope of f at x equal 2 is the same as saying the derivative of f at x equal 2.
Okay.
2 more. Okay. Question says, for what values of x is f not differentiable? Okay, new word. F is not differentiable. That means where is the derivative of f non-existent or undefined? That's what it's looking for. Where is the derivative of f undefined? So here's a box to help you. It's on your your notes. This formula we will not use in Unit 1. We will not use it till Unit 2. So the formula you don't need to worry about right now. You just need the words. Okay, f is continuous. Sorry, f is differentiable as long as f is first continuous. If there's a place where f is not continuous, you can't find the tangent slope at a discontinuity. For example, at x equals 0, f has a jump. Now I showed you the Desmos thing, where you pick a dot, and you draw a secant to the left, and you draw a secant to the right. So I draw a blue secant, I draw a red secant. Like that. You're then going to move the secants closer and closer together. So the blue secant kind of moves like this, and then like this. The red secant does something like this. I wanted to get this in Desmos, but this is pretty challenging to get this to work in Desmos. So the secant slopes get shorter and shorter. Raise your hand. Each of those blue secant slopes, are they all positive, are they all negative, or do they change? Hands up. Those blue secant slopes, are they all positive, are they all negative, or do they change? Those blue secant slopes, Carter?
They're all positive.
They're all positive. How many knew that? 2 more. If a line looks like this, that's a positive slope. So the blue secant slopes are all positive. And they're getting, just say it out loud, more positive or less positive? Say it. More. The blue secant slopes are headed towards positive infinity. The red secant slopes are all negative, and they're getting closer and closer to negative infinity. So the two slopes are not getting closer together, they're getting further apart. That's why the function is not differentiable at that discontinuity. If you have a discontinuity, you can't find a slope at a discontinuity for that reason, because you can't get the two secant slopes to ever become the same slope. Please.
How is red getting closer to negative infinity?
So the first red secant I drew looks something like this. Is that a positive or negative slope? No, when the slope goes like this, that's a negative
Oh,
slope.
it's right. Okay.
No worries.
Oh.
You see it now?
Yes.
You good? 2 more, Jackson. Anybody else? Okay. The function is also not differentiable if there's ever a vertical tangent, because the slope is undefined. You can't find a slope where that slope is vertical. If the function has what's called a corner, corner is my word, but it's easy to remember. That's a sharp point on the function. You can't find the slope at a corner either, for the same reason as you can't find the slope at a discontinuity. So this particular graph has a place where you can't find the derivative, it's not differentiable at x equals 0 and x equals 2. Please, Cora.
Why not 4?
Oh, 2 more for Cora. If I try to find the slope at x equals 4, here's my problem. I can draw a secant to the left in blue. Green, I guess I'll have to do. And I can make my secant shorter and shorter to the left. You good with that? I cannot draw a secant to the right. There's nowhere to draw it. So actually the function is not differentiable at x equals 4 as well, because a function is never differentiable at an endpoint, because you can't draw the other secant slope. They just didn't ask about it. It said for values less than 4.
Okay, I'm still confused on why 0 would be different.
So f is not differentiable at this point, because at that point I have no way to find the slope right there. Because the only way I can find the slope is by drawing 2 secant lines and then making those secant lines shorter and shorter. And hope that the 2 secant slopes get closer and closer to having the same value, and they won't. 2 more, please, Carter.
So in this case, it's almost like at point 2 it said it had a vertical tangent, and at point 0 it's kind of similar because also you have that jump.
Keep talking.
Same idea. But instead of it connecting all the way through, because it wouldn't be a function.
That's true as well, plus all those slopes would be vertical. They'd all be non-differentiable. Can't tell if you've sorted it out or not.
It makes sense to me.
Okay, 2 more. Please, go ahead.
So I see 0, it's not continuous, so it's not differentiable. I don't quite see why 2 is differentiable.
Oh, no worries. So I think this will help, Conrad. If I asked you to tell me the tangent slope of f at x equals 2, what would you tell me that slope is?
Undefined.
Undefined. That means not differentiable. Undefined slope means I couldn't find the derivative, which means it's not differentiable. That's just the wording. You're good?
Yeah.
2 more. Look up. Just a reminder, you're doing great, you really are. This is Unit 1. Okay, Unit 1, when you take the test, it's like, okay, you do need to bring a pencil, because you got to fill out a bubble sheet. But you won't use the pencil for a whole lot else. Because most of the questions are this style, where there's nothing to write down. It's like you have to understand the language, you have to understand the rule, the idea, and then you have to apply it. Okay, so just doing great. Very good here. Got time for a little bit more, so don't go your way yet.